Good day. Here we have another, and yet another, continuity question. So determine the value of k so that the function f of x is continuous everywhere. So, okay, this is naturally a piecewise function, and I'm just going to graph the part that we know actually, just so that other students that learn very visually can have a reference here. And so we got x squared minus 1, that's a parabola with a vertex of 0, negative 1. Right? But it only goes up until the value of x equals 2. So it will look something like this. Oh, God. Okay. I'm going to try not to make this look absolutely horrible. Okay, so something like this. Up until 2, and including 2, so I can draw a closed dot there. Then over here, to the right of 2, and that is of course because x is smaller than or equal to 2, and this continues forever. So over here, we don't know what's going on yet. We just have 2x plus k. We want to make the function continuous everywhere, so we want the function to connect, and it's going to have a slope of 2. It's just going to be basically a linear just a straight line here, right? But we need to figure out what this value of k is in order to make this happen. And how can we do that? Well, first we need to determine the limit as x approaches 2 from the left of f of x. And that's actually just going to be the value when we plug in a 2 for x squared minus 1. So 2 squared, 4 minus 1, 3. So this is the limit of the function as x approaches 2 from the left, just 3. And we need to make the limit as x approaches 2 from the right the same. Otherwise, there won't even be a limit there. And remember that one of the conditions for continuity at a certain value of x is that the limit as x approaches that value, in this case 2, must exist. And these two need to be the same for that to happen. So the limit as x approaches 2 from the right of f of x is equal to 3. We must force it to be 3. And what is this going to work out to be? Well, it's actually just 2x plus k. Because when x is greater than 2, f of x is 2x plus k. So 2x plus k is equal to 3. So what's k? Well, what is our x value? We're interested in the limit as x approaches 2 from the right. So I can plug in a 2 here. So 2 times 2, 4, plus k equals 3. Subtract 4 from both sides, and k is equal to negative 1. Fantastic. So if k is negative 1, this will happen. The two lines will connect right there, that point 2, 3. And the function will be continuous indeed everywhere. And how do we know that? Well, for any polynomial, like x squared minus 1, the function is continuous everywhere. And for any linear function, the same, of course, because a linear function is a polynomial function. And this is what we have here. We have just y equals 2x plus, minus 1, because k is negative 1. So that's it. K is negative 1, thereby making our function continuous everywhere.